A machinery pier of 3 meter by 4 meter supported a vertical load of 80 kilonewton as shown in figure. Find the stresses developed at each corner of the pier. First of all, write down the given data. The width of this pier it is given B is equal to 4 meter. B is equal to 4 meter, and depth, that is thickness, it will be given D is equal to 3 meter. Okay. Then eccentricity of about x-axis, Ex is equal to eccentricity about x-axis will be given 0.5 meter, 0.5 meter, and eccentricity about y-axis, that is Ey, Ey is equal to 1 meter, 1 meter. So this data it is given for, and P load, vertical load it is given, it is located in here. This one it is location, it is in shown in red. Okay, it is marked as a red. Okay, this one it is location of load, P load, that is P is equal to 80 kilonewton. P is equal to 80 kilonewton. Okay, kilonewton. Okay. So first of all, find out the area of this column. A is equal to 4 into 3. 4 into 3. That is 12 meter. 12 meter square. 12 meter square. Okay. And find out moment of inertia. Moment of inertia. Moment of inertia. That is first I-axis is equal to BD cube by 12. B into D cube by 12. So B it is width, D it is depth. Okay. BD cube by 12. Moment of inertia about axis. So B it is 4 meter, 4 into and 4 into 3 cube, 4 into 3 cube divided by 12. 4 into 3 cube divided by 12. 4 into 3 cube divided by 12. We will get I-axis, moment of inertia about x-axis, 4 into 3 cap 3 divided by 12. So this one it is 9 meter square, 9 meter raised to 4, 9 meter raised to 4, 9 meter raised to 4. Then next IYY, I will note down this value. So I-axis is equal to 9 meter raised to 4, and the area is 12 meters square. Okay. Then next IYY, moment of inertia about y-axis, IYY is equal to dB cube by 12. Will be D into B cube by 12. dB cube by 12. dB cube by 12. Is equal to 3 into 4 cube, 4 cube divided by 12. Divided by 12. I1. It will be dB cube by 12 in I1. So D it is 3 and B it is 4. So 3 into 4 cap 3 divided by 12. So this one it is 16 meter raised to 4. 16 meter raised to 4. So this one it is moment of inertia about IYY. Okay. So IYY is equal to, I will note down this value, IYY is equal to 16 meter raised to 4. Okay. So next calculate moment about the x-axis. Okay. Moment about the x-axis. So Ex value I will note down, Ex is equal to 0.5 meter and Ey is equal to 1 meter. Ey is equal to 1. So now first find out moment about the x-axis. Moment about the x-axis and x-axis. mxx. Okay. So P into EX, P into EX. So P it will be load 80 kilonewton and moment eccentricity about the x-axis is 0.5 meter, 0.5 meter, 0.5. So it will be get mxx is equal to 80 into 0.5, it will be 40 kilonewton meter, 40 kilonewton meter. Okay. So mxx is equal to 40 kilonewton per meter, 40 kilonewton meter. Now myy, moment about y-axis, myy is equal to p into e1, p into e1. So p it will be 80 kilonewton and ey it will be 1 meter. Okay. So moment about myy it will be 80 kilonewton meter, 80 kilonewton meter, 80 kilonewton meter. So now we need to calculate stresses at each corner. Okay, stresses at each corner. So first of all, we calculate the stresses at sigma a corner, at a corner. Okay, at a corner, okay. A corner is equal to so direct stress P by direct stress P by direct stress P by direct stress P by then bending stress about the x-axis. Okay, so about the x-axis bending it will be same because it will be in the region of x-axis only. So that's why we take plus value. Okay, so mx into y bar divided by ix, y bar divided by ix, y bar divided by ix. So why we have taken this one plus value? Because about the m-axis, moment about the x-axis, it will be above the this value it will be above the x-axis. Okay, means in the above the x-axis. That's why we are taken this one. It is plus value. Okay, then minus. Now why it will be minus my? Because it will cross the y-axis. So y it will be cross the about the y-axis. That's why it will be taken minus. Okay, so my into x bar into x divided by iyy divided by iyy. Okay, divided by iyy. So we need first of all x and y. Okay, so x, so distance between x means distance between xx to xx to xx to corners a and b, corners a and b, corners a and b, a and b. So it will be get x is equal to distance, x is equal to it will be 2 meter, x is equal to 2 meter. And same distance between yy, distance between, sorry, this one it will be distance between yy, distance between yy axis to corners a and b, corners a and b, corners a and b. Okay, so yy to corners a and b, that will be x is equal to so this one it is 2 meter. Okay, this one it is 2 meter. So yy axis to corners a and b, this distance it will be 2 meter. Okay, here this it is yy axis and this one it is corner a. So yy axis to corner a it will be 2 meter and yy axis to corner b it will be 2 meter. So that's why x is equal to 2 meter. Then distance between between x axis to corners A and B, corners A and B, corners A and B, A and B, corners A and B. Okay. So this distance will be y bar, y. Okay. Y is equal to from this distance x axis, so it will be 1.5 meter. 1.5 meter means this distance. This distance x axis to corner A. So this distance it will be 1.5 meter from the x axis. So that's why y is equal to 1.5 meter, and distance from y to corner A and B, this distance. This distance it is 2 meter. Okay, so that's why 1.5 meter and 2 meter. Okay, so now put all this value here. Here all this value is equal to it is 80 kilonewton. It is 80 kilonewton. Cross-sectional area it is 12 meter. 12 meter. 12 meter. Then plus an x moment about the x axis, it will be 40 kilonewton meter. 40 kilonewton meter, and y it will be y 1.5 meter. Y it is 1.5 meter. Y it will be 1.5 meter. So I will note down x is equal to 2 meter and y is equal to 1.5 meter. Divided by Ixx. Ixx we are calculated Ixx 9 meter raised to 4. 9 meter raised to 4. Then minus myy. So myy we are calculated, it is 80 kilonewton. 80 into, then x value to be 2 meter, divided by myy. Sorry, Iyy. Iyy it will be 16 meter raised to 4. 16 meter raised to 4. 16 meter raised to 4. So we get stresses at A. 18 by 4. 18 by 12. 6.67. 6.67. Then plus 4 into 40 into 1.5 divided by 9. Will be also 6.67. 6.67. Then minus 80 into 2 divided by 60. It will be 10. So stresses at A, 6.67 plus 6.67 minus 10. It will be 3.34. 3.34 kilonewton per meter square. Kilonewton per meter square. Okay. So this one is stresses at A. So now calculate stresses at B. Stresses at B. First of all, write down first one. Sigma B is equal to stresses at B. Sigma B is equal to. So location of load it will be at B, near to the B corner. Okay, so that's why we write down all these are the in positive. So P by A, then plus mx into y, mx into y divided by Ixx divided by Ixx divided by Ixx. Then plus my into x divided by Iyy divided by Iy. Okay. So P by 8 is 6.67, 6.67, then plus mx into y divided by xx, it will be 6.67 again, 6.67, then plus 10, then plus 10. So stresses at B, it will be get 6.67 plus 6.67 plus 10. It will be 23.34, 23.34 kilonewton per meter square. Kilonewton per meter square. Kilonewton per meter square. So this one is stresses at B. Now stresses at C. Calculate stresses at C. Stresses at C. Sigma C is equal to stresses at C. So first of all, write down the formula. Stresses at C. P by A. P by A. P by A. Direct stresses is P by A. P by A. Then P by A. Now it will be C. It will be here. Yes, it will be here. So this it is crosses the x-axis. Crosses the x-axis. But in the region of y-axis, before y-axis. Okay. So that's why it will be write down plus, sorry, minus. This crosses the x-axis. That's why mx into y, mx into y divided by axis. Divided by axis. Divided by axis. Then plus y. Why it will be plus? Because it will be not crosses the y-axis. Okay. For what? For this one, it will be not crosses the y-axis. So that's why it will be take plus my. So my into x divided by I1. Okay. This one it is not cross the y-axis location of this loop. So that's why we are taken here plus. Okay. Here put all this value. So P by 8 is 6.67. 6.67. Then minus 0.1 kilonewton meter square. 10 kilonewton per meter square. Meter. Okay. So this one it is stresses at C corner. Now stresses at D corner. Stresses at D corner. Stresses at D. Sigma D is equal to stresses at corner D. Okay. Stresses at corner D is equal to P by direct specific P by then minus mx into y divided by ix. Y it will be minus iy. Sorry, ix. Yes. Why it will be minus? Because this location it will load here. So it will be crosses the x-axis as well as y-axis. So both we take it is minus because it will be acted totally opposite of this location. Location of load it will be acted opposite of this region. Okay. So that's why we take both the minus value. Minus my into x my into x divided by ix divided by iy divided by iy. Okay. So write down stresses at C, it will be 6.67 direct stress, then minus 6.67, then minus 10, minus 10. That will be get 6.67, 6.67 minus 6.67 minus 10. It will be get minus 10 kilonewton meter square, minus 10 kilonewton per meter square. So minus indicate it will be tension. We can write down it will be 10 kilonewton per meter square, and in bracket we can write it will be tension. It will be tension. So stresses at D, it will be tension. Okay, tension. Okay. So once again I will explain why it will be minus and why it will be this way. At corner C, it will be direct stress P by A. So mx, x-axis it will cross this axis, it will be cross opposite of this load location. Okay, that's why it will be take minus, and it will be in the region of y-axis, before y-axis. So that's why it will be take plus. Okay, here at D, it will be cross the x-axis as well as y-axis. That's why we have taken moment about x-axis also, bending stress about x-axis minus, and bending stress y-axis it will be also taken minus. Okay, so this one it is stresses at each corner for this given machinery dimension. Okay, the location of load it will be located in this region. Okay, so for that A, B, and C corner, the stresses act for compression, but at D it will be in tension.